Hello, everybody. This is the discussion call for CHIP-53, authored by Dan Perry. Dan, take it away.
Thanks, Jude. Oh, we've got a few people joining. I'm just going to share my screen here. I don't have a super fancy presentation, so I'm just going to go through the chip and hopefully that's good enough. I'll start with just a little bit of history. So, Secure the Bag was originally proposed by Jeremy Rubin in 2019. I'm not sure if he still is super active with Bitcoin, but at least at the time he was a Bitcoin core developer. And he came up with this idea for creating a tree of coins to make bulk payments that made it more efficient to pay out a bunch of coins to a bunch of different people. And about a year later in 2020, he took that and then some other stuff and combined it into a bib called Op Check Template Verify, CTV. And I have a link to it here. We can look at it. It was proposed in 2020. It's still a draft, so I don't know if it'll ever get done, but that's on Bitcoin, and that would give Bitcoin basic covenants and this language for what do you call it? Conditions that we already have all this stuff in Chia Lisp or CLVM. It would at least get them part way, but alas, it may never actually happen. But the idea of secure the bag lives on because a couple of years later, in 2022, we at Chia had to do the Cat 1 to Cat 2 upgrade. And so what we needed to do was get a list of every single coin that existed for a Cat 1. And for each coin that there was, we had to create a new coin of the same value and airdrop it to the same address so that you get an exact copy of the coins that you had, but now they'd be upgraded to the new standard. So the easiest way to do this, of course, would just be to create a new coin for each coin that existed, but then it wouldn't be particularly efficient if for example, if we had to create a million coins, it would be a million spend bundles and a million create coins. Um, so Freddie, who works for CNI, came up with the plan to adopt Jeremy Rubin's secure the bag idea and make this tree of coins to do this airdrop upgrade. And it worked out really well. And so that was, I think, the first real world use case or usage of secure the bag. And in the chip, I give one example of just how much more efficient it is in some way. It's not like a magic bullet or anything, but in some ways it's more efficient. That if you have a million coins, instead of having to create a million, you'd only have to create 10,101 spend bundles. So you'd save about 99% as far as that number. And the great thing there is that instead of one central entity having to create every coin and then spend them all into the destination addresses, the coins are bundled, and I'll get to exactly how this works, so that only one person out of the last intermediate coins has to actually spend the coin in order to distribute the payments to everybody who gets payment from that coin. So now let's fast forward to today, and we have this thing called Permuto, which I'm not going to talk much about what Permuto is. There's plenty of other presentations about that, but it's this single shareholder trust, and the first one is going to be Microsoft. And I'll just use that in the examples here. So if you hold a dividend certificate of Microsoft, then every 3 months you'll be entitled to get a dividend. And so the way this will work is Microsoft pays the trust the lump sum amount for the dividends that need to be distributed, and then the trust has to give them out to everyone who holds the certificates. Um, this is basically the same thing that we did with the Cat 1 to Cat 2 upgrade. We're just swapping out some names here. So in the Permuto case, we need to give dividend payment. It's going to be a stablecoin payment to instead of Cat 2 to everyone who holds a dividend certificate. So again, we could just give out the coins directly, but secure the bag just makes a lot of sense here to save some coin spends and to distribute all these rewards. So far, none of this is really new technology. We've already done this, like I said, but we still have a couple of questions that were left unanswered, and that's what this chip's trying to tackle. These two main questions here. So one is, let's say that I'm going to receive one of these rewards as a dividend payment for Permito, and we could generalize this for other use cases beyond Permito as well. This could be, I mean, for example, you might have an NFT collection that you want to airdrop tokens to every holder of that NFT collection. But in the case of Permito, let's say I know I need to get a dividend. There's a bunch of these coins that are intermediate coins. I know what my dividend is in one of those coins, but I don't know which one. So how do I know which one is mine? And then the second question is, well, what we have this issue with distributing the coins unevenly. So how do we organize them is, I guess, the main question. So I'll tackle this one first, the how do we organize them question. Let's say we just took a list of every single coin at the X dividend date or block height. We just take a snapshot of the coin set on the blockchain. And now we have a list of every single coin that needs to get a dividend payment. Well, how do we organize them? One way to do it would be just alphabetically by like XCH address. Another way would be start with the lowest coins and then lowest value coins and move toward the highest. And then another way would be reverse that, high to low. Maybe another strategy might be random, but all of these have some issues with them. So let's say that we go high to low. We bundle, and let's just say we use 100 for the number of coins that are in one payment, one bundled payment. That's a pretty happy medium, and I'll discuss exactly why that is later. So let's say we take 100 coins and bundle them in. Um, if we start with the highest value coin, well, maybe just as an example, maybe the highest coins value for Microsoft dividends, maybe it's 1,000. And Microsoft, if I remember right, is going to pay, at least currently, pays 91 cents for every dividend certificate that you have, and that's 4 times per year. So if you have a coin worth 1,000 DCs or 1,000, yeah, I guess DCs, then you would have to get $910 for your dividend payment. So that's a pretty big amount. And let's say the second biggest is like $900, and then the third biggest, I don't know, $880, and so on down the line. Um, One person out of the top 100 has to spend that coin, and anyone can spend it, and it doesn't require a signature, so that's one great thing. And no one can modify what happens when it gets spent, so that's another great thing. The dividends are going to get paid out, but someone has to spend it. So now let's pretend that we live in this future world where the blockchain's super busy and there's consistent fees that are needed. So maybe it's like $1 for each transaction. In that case, would somebody who's in that top bag, that top 100 coins, be willing to spend $1 to get their payment? Well, yeah, of course, because if I'm going to get $910, then sure, I'll spend $1. And then everyone else gets their payments automatically. They don't have to spend any money. That's fine. But now at the bottom of that list will be all the lowest level, lowest value coins. So maybe the lowest one might only be like 1/100th of a DC. So that person is only going to get zero point 0.9 cents. Okay, less than a penny. And then maybe the next one gets a penny, the next one gets 2 pennies. So who's going to spend $1 to gain 2 pennies? That just doesn't make sense. So if all the lowest value coins are bundled together, there's a good chance that coin just won't ever get spent, or at least not until there's no fee at all required. So what we want is a way to distribute the payments evenly so that every single one of these it, coins that needs to get spent contains some high value payments and some low value payments. And so that's what this chip is trying to do. And the second thing it's trying to do is standardize how this all works so that any wallet will, with a bit of extra information, will be able to examine the blockchain and then determine which coin that person needs to spend. So I'll go onto my Cloud wallet or my Sage wallet if they implement this, and I'll get a note saying, "Hey, by the way, there's this coin that if you spend it, you'll get a dividend payment." or you can wait for someone else to spend it. So what do you want to do? And so it'll know which one to spend. So those are the two questions. And the rest of the chip is just basically how to do it. There's a bunch of information about how secure the bag works, but the meat of the chip is just those two things. So I'll just go over how this works and give some examples, and hopefully it'll all start making sense if it doesn't already. So what you do is you start out at that the block height that you want to freeze, that you want to take a snapshot for, and you get all of your addresses. That's very straightforward from just the blockchain database. And all you need is the address and then the amount of coin that you're going to send to that address. And organize them by from biggest to smallest. And that'll become apparent why you're doing that in a minute. Um, then I give a bit of info here about cats and how big this is the smallest value cat is 0.001, and the largest value possible cat is quite large. You're never going to need that big. Um, Once you have this list, this CSV file, you just need to come up with a couple of variables and then you're good to go. So D is going to be the number of lines in the input value. So that's just how many payments you need to make. You need to create in this tree some intermediate levels. Often you're only going to need one intermediate level, and this just depends on how many payments you need to make. And uh, if you have to do less than 10,000 payments, then probably just one intermediate level is fine. Typically, and I have here the highest value that you could probably get away with for how many coins to bundle together into one is around 300. But if the blockchain is super busy, it might be difficult to spend that coin because you're going to have to buy a large percentage of the block in order to do it. So 100 is typically a good amount to bundle together. It's a good happy medium where let's say I only bundled 10 in that final bag, then one of the 10 people who are receiving that payment would probably want to spend that coin. I mean, anyone can spend it, but only those 10 will get anything out of it if they spend it. That's probably too small of a number. So we want to go higher than that. But if we go much higher than 100, then we run into the other problem where it gets harder and harder to spend the coin, or the fees get higher and higher. So typically 100 is good. And let's see. So this is just how to calculate those intermediate levels. And the great thing about this secure the bag in general is that it scales logarithmically. So if we use that 100, then we can multiply the number of receive addresses by 100, and all we have to do is add one extra level. So with just three intermediate levels, we can spend up to 100 million coins, which is quite a lot. And you can add more levels if needed. Then there's just a couple more variables to get. The C is going to be the number of the maximum number of destination coins that will be bundled together. You have to use a maximum because if you have an uneven number of coins in total, which I'll show you an example of this, the destination coins won't all have the same number. They just can't because they don't divide evenly. And then N is the total number of coins to be created in the final level of the intermediate coins. And that is just a formula. It's always going to be D divided by C. And you have to round up, always take the ceiling. And with these intermediate levels, you always are taking the ceiling as well. And so to create a secured bag, you iterate through that input file. And remember, it's ordered by largest coin first and then smallest last, and you're using modulo. So you basically just want to take each line in and add a coin for each intermediate, add that coin into the next available intermediate coin, and then loop back with modulo. So what you end up with then is, let's just take the example where we have 10,000 coins total, and then we're bundling those into 100 intermediate coins, each of which have 100 payout coins, destination coins. So every single one of those 100 coins using this method is guaranteed to get one of the highest 100 value destination coins. So, and then it's going to get one of the 100 lowest value destination coins as well. So you have basically the maximum distribution possible so that every single coin has a nice mixture of large and small ones that it needs to pay out. Uh, so then you're going to bundle the intermediate levels once you have that final level all sorted. And depending on how many levels you might have to iterate on this a few times. And then the final step is to bundle the intermediate coins into the secured bag. So that's one coin. And then to spend or distribute the secured bag, you just work backwards. So you start with one coin and you spend that. That creates a bunch of coins, which when spent can create a bunch more coins, and it grows exponentially. So I I think this maybe makes the most sense by just using some actual examples here. So the first example that I have is, let's say there's exactly 10,000 coins that we need to pay out. So again, these are like in the Promuto case, this would be, for example, that 10,000 people are holding dividend certificates for Promuto, and we need to give payments out to of varying levels to each of those 10,000 holders. So we'll use oh, sorry, this is fewer. The first example is only going to have 5,000. This it has fewer than 10,000, so there's only going to be we will only need one intermediate level. So let's just say there's 5,000. That intermediate level is going to have 100 coins in it, and C would be, if we just go back up here, the maximum. Where'd it go? The maximum number of destination coins to bundle together. This is always going to be 100 unless you have some really good reason for it not to be. And then to get n, you just take d divided by c. So 5,000 divided by 100 is 50, and those are the only variables that we need to figure out ahead of time. So first we'll iterate through the 5,000 lines, create those 50 intermediate coins, and each of those will contain 100 destination coins. So again, 50 times 100 is 5,000. So 50 coins to distribute 100 rewards per coin. And then we'll bundle those 50 coins into the secured bag to get our resulting tree. And then to unroll it, all we need to do is someone needs to spend the first coin, and that can be anybody. And the next step, that will create 50 intermediate coins, and then each of those will have 100 coins in them, so anyone can spend those, but then hopefully we'll have somebody who's got enough value in those coins to spend them. And once those coins are all spent, then the bag has been completely distributed. One good reason to do it this way is at first, maybe Permuto might just spend these coins on their own because literally anybody can spend these. But over time, Permuto is planning to have like I forget the exact number, something like 90 different trusts. And if that actually happens, and each of them has to pay dividends 4 times per year, that's essentially one dividend distribution every single day. So this is the kind of thing that really adds up. And if you're distributing millions of payments for each of these, then well, you don't really have time to dilly-dally. You can't it's really not going to be easy to create individual coins for, millions of times daily. So these bundled payments work well. And then when you think about it, if let's say there are a million holders of one of the trusts, well, that's going to be 10,000 of these final coins that have to be spent. So if it's $1 per coin, that's $10,000. And if Permuto has to pay that, then that's $10,000 basically every single day. This is obviously um, down the line once Permuto has actually started all of these trusts, but we're just trying to think about the future here that it ideally we'd get one person from out of these 100 coins to spend it. So another example here is, I mean, the first one was a very nice number to work with, just 5,000. But let's say we have 10,001. This is one coin larger than we can get away with with just having one intermediate level. So now we have to add a second intermediate level. So if we use the formula that I put at the top, then I1 becomes 2, and the second intermediate level I2 becomes 51. C is always 100, and then to get D or N, you take 10,001 divided by 100 is, well, a little over 100, but you have to take the ceiling, so 101. So then this time you're going through the 10,001 lines and you create 101 intermediate coins. And the idea here is you could potentially create just 100, but then we're making a rule that we don't want to ever have a coin with more than 100 create coins in it because then it starts to get harder to spend it. So you want to get it to as close to 100 as possible. And by just using the algorithm that I put at the top with using modulo, you'll end up having two coins have two of the intermediate coins have 100 destination coins in them, and then the other 99 each have 99 in them. And then if you add these up, 99 times 99 plus 2 times 100 is 10,001. So that's why we come up with those numbers. And you end up with just two coins. So now we can, or sorry, step two would be we have 101 coins. We bundle them into two. And the final one is we bundle the two coins into one. And then unrolling is the same thing. We just, anyone can spend the top one, which creates the intermediate coins. Anyone can spend the intermediate coins, which creates more intermediate coins. And then finally, we get 101 of these final intermediate coins to distribute the actual dividend payments. Okay, so that's a couple of examples. I think I have one more example in here with a bigger number, but it's the same type of technique. And so yeah, I mean, I don't think this chip has been implemented at all yet, but initially we might not be this smart with Permito. We might just be more random with how the coins are distributed, which is probably okay at first. But if, like I've said before, if this ever takes off and we scale the project pretty highly, we're going to need something that's more efficient like this. So that's why I created this chip. So, any questions from anybody?
Go ahead, yeah.
Yeah.
Yes, thank you for the great presentation. I think it's very important to go into details about the algorithm because in a future with multiple wallets, it will be important for anyone having the CSV file and the few numbers, the few parameters to reconstruct this so they can enroll the coins they are interested in. So my first question is, I have an observation. I think I might have missed if this was pointed out, but I think another nice property of secure the bag is you can basically defer transactions for later. So if you have to pay dividends for Permuto at a certain day, you can pay a pretty high fee and you just create the secure the bag coin. And then everyone that wants to claim dividends might be okay with waiting, say, 2 more hours and then getting their dividends when the network fees are lower. Um,
Yeah, I can address that quickly before you get to your next question. Um, you pretty much are spot on. I don't think I mentioned actually that the top coin that gets created, it's kind of cool. It'll have the entire value of all of the dividends bundled together. So it might be a really big value coin. And then that coin can be spent at any time in the future. So that's really nice. The thing where you might be a little bit off is the actually creating that coin. What Permito is going to do is take the block height that we've decided, and I forget exactly how we determine this. It's like 4 p.m. Eastern on a certain day. That's all in the S1 documentation. But we're going to take a specific block height and use the coin set from that height. It's going to be frozen in time. So if you own the coin at that height, you'll get your dividend. So there's no extremely fast rush that we need to create the secured bag immediately or anything like that. But you're right, we do need to create it pretty promptly, especially if we're going to be doing this almost every single day. So once we've created, or Permito, I shouldn't say once Permito has created that secured bag, it's out of their hands and it can be distributed at will, slowly if needed, just like you said. So yeah, that is another really nice feature. So thanks.
Also, once the initial coin is created, everyone knows they'll get the dividends after they unroll the coin. It's not a question, like, are there funds, or you know for
Right.
certain the coin is on the blockchain. And
Right, your coin is
uh,
in there. Right.
yeah. So well, I think this is pretty comprehensive. So my only question is, do you have any thoughts on discovery? Because usually, for context, when people receive assets, you create a coin and you hint they're receiving custody puzzle hash, and that's how wallets usually discover. Here, it will be a bit more complicated because you have potentially so many recipients, and there's also a centralized API involved to get data to unroll the bag. So, are there any thoughts on discovery, or is that beyond the scope of the chip?
No, so this is in the scope of the chip, and I think this we're still pretty early in the chip's development. Like I said, it hasn't been implemented yet. Brandon, do you have any thoughts on how to do the discovery part?
No, pretty much as far as I've gotten is having an API that gives a CSV file or something, but you still need a way for the wallet to know in the first place that its address belongs to a coin inside of a bag. So I'm not really sure how that would work.
Okay, sorry to put you on a spot there. Um, but he's going to be helping implement it. So yes, we do need to have a standardized way that any wallet could use based on just the blockchain data. And then I was thinking we'd maybe publish these variables. We maybe even would publish the CSV. And at least from the CSV, any wallet should be able to reconstruct exactly how the secured bag looks so that any holders within that wallet could discover it. So it'll be a, hopefully a wallet SDK call, and but we're not quite sure what that'll look like. More questions from Yak.
Just one comment. Sounds like if you have a way to maybe send messages to token holders, this would be a new type of message. Like, we just created a dividend. Here's the API base URL. Uh, yeah,
So there may or may not be such a messaging system coming soon to the cloud wallet. Keep your eyes open. But yes, that's a good call.
Yeah, I think the What SDK part of that is already open source, so people probably already know about it.
I
So
believe
there
we
you
have
go.
a
So,
I believe we have a chip coming for that as well, right, Dan?
oh, I don't think we've talked, maybe we've talked about one, but I don't know if one has been written. So, but we should, yeah, that's a good point, Jude. We should have a chip for it so that other wallets can take it and use it.
I think I saw a very early draft chip, but it needs to be more than a very early draft.
Yeah, yeah.
Um, One question slash comment from me. So the original Bitcoin version of Secure the Bag, something that really emphasizes is the idea of lazy unrolling. And we've kind of implicitly talked about that a little bit, but just to call it out a little bit more, kind of part of the core design on the Bitcoin side is the moment the secured bag hits the blockchain, the intent is for every wallet to immediately be able to say, oh, okay, I have these things. They are inevitably mine. And then just treat them as owned assets. And then the idea is that rather than people proactively unrolling things, although you could do that as well, um, the wallet would simply, when the first time it wants to spend one of the coins that has been secure the bagged to it, that is then the moment that would trigger the unroll. I think you have
Hmm.
all the pieces of that here. I'm curious if the intent is to head in that direction for the Chia wallets as well. and if there's anything beyond what you've specified here that would be necessary to realize that vision.
Yeah, actually, I hadn't really considered that. That is an interesting idea. I think we'd have to think about that if we'd want to implement it that way, because you'd still need two coin spends, right? If you unroll and then send to somebody else, because the coin has to go to your wallet first. Uh, could we even use fast forward in that case for the to do the unroll and the send at the same time? I think we'd have to think about that. Otherwise, yeah, I guess it kind of makes sense that there's no need to spend it until someone needs it. I guess in a way, we do something similar with clawbacks, with clawback V2, where once the timer expires, there's no additional coin spent. The wallet just assumes the coin is yours. And the sender of the clawback could still spend the coin and then make it official. But otherwise, the wallet just says, yeah, that's mine because nobody else can actually spend it or it can't be clawed back anymore. So I guess it's a kind of a similar idea.
I
Hmm.
mean, I do still think that your mechanism has an advantage because, if I receive a dust level version of one of these coins and then I lazily unroll it, I might still have to pay the higher fee more than the coin's worth to actually do the unroll. So I think the incentive structure that you're setting up still makes sense. However, when the costs are low, gosh, I sure do love the mechanism of the secure the bag hits the chain and then all the wallets immediately say, "Oh, look at these coins I have."
So there's I know fast forward won't work for this because it's not a singleton, but there's a separate mempool feature called identical spend deduplication that would allow if two people spend the or do the unroll at the same time, the mempool will just combine those two spends together into one. Because it's the same puzzle, same solution, and same coins.
Okay,
Uh,
there you go. So we could potentially add that to this chip in that case.
yeah, but I think the difference between that and clawback V2 is that with clawbacks, you have a very low risk of someone interrupting your coin spend. Um,
True.
if you like, someone could complete the third spin path that sends the clawback coin through to the address of the receiver, which might conflict with a separate spend bundle that spends it normally with the receiver's puzzle. But with the secure the bag coin, there's like 100 different recipients, so there might be more contention on spending that coin.
Yeah, that's true. Yeah, I mean, I always just assumed that the way I was structuring this, that someone would want it right away. And that's mostly going to be the really high value holders. But maybe there's some edge cases where, or this isn't necessarily just for Permito. This could be for other things. So maybe there's some other use cases where waiting is fine. Yeah, and the clawback, I guess there is one type of attack, like a griefing attack, where the sender sends you a bunch of clawback coins and then proceeds to spend them whenever you try to spend one of them. But
Yeah, it's only a temporary thing though, because I can only do it one time and then it's your
yeah,
coin.
yeah, just once per coin. And if they dust you, you could always ignore it.
So something I was considering requesting in this chip is um, a example implementation written in code rather than just as the written out algorithm. Um,
Mhm.
I feel like that would be a good idea, but I don't think it's a strict requirement. I was just curious about, Dan, your thoughts of providing that for the algorithm as well.
Yeah, I mean, I think we should get that out before we finish the chip. It's still a draft, and so it should probably sit in draft until we have an actual implementation. I suppose it could just be completely informative. Oh, It's a guideline is the category. As a guideline, I guess we could potentially push it through with just this, but it would be nice, I think, to have an actual implementation.
Um, is it useful to think about the secure the mint variant of this, or is that better kept as a wholly separate scope? So secure the mint being this technique applied to the minting and distribution of NFTs. And it's something that Mint Garden invented and they use in their algorithms right now.
Right, it's another thing I haven't considered. So I maybe I should talk to Andreas about it if he thinks makes sense.
I think the intermediate coin part of this would make sense for that, but distributing based on amount wouldn't apply to NFTs since they all have one mojo.
Oh
Unless
yeah,
you
that's true.
unless you somehow like quantify the value of an NFT in a collection or something.
Right. Oh yeah, I mean, I guess if it's possible to do, yeah, that would make sense in some cases. You might create an NFT collection that's 10,000 NFTs that you have a pretty good idea what the ranking is going to be, and then airdrop them that way.
Yeah. I do think if this is generally an efficient algorithm, then it would make sense to standardize on this as much as possible. That way, wallets that have to reconstruct the unreal spend bundles will have a consistent way to do that, rather than having a bunch of different implementations of the same thing.
Yep, true. Yeah, ideally, I want it to be that if I have my DC in Sage, that Sage can use, well, a combination of this messaging protocol and then this secure the bag and say, okay, you've got this coin. So once it's spent, you'll get your payments. Would you like to spend it now or would you like to just wait? So, any other questions or comments? Feel free to leave comments in the actual chip.
I do think it's worth noting that with like in a regular spend bundle to make payments from a coin, you can include multiple outputs. And so this using secure the bag doesn't necessarily well it doesn't decrease the CLVM cost, it actually increases it. So maybe it's worth noting that in the chip as well as what the benefits of using secure the bag are, like the committing to the list of payments up front and allowing people to pay fees for their own unrolls and so on.
Yeah, it sounds good. I'm glad this is being recorded so I can just remember, or I don't have to remember it all. Just watch the recording. But I'll go through all the questions that have come up.
Um, Question for rigidity. From the perspective of somebody making and maintaining a wallet, I guess what is the easiest way that you can imagine to discover secure the bags happening in the ecosystem that you can then display to the wallet holders?
I do like the idea of having a bulletin coin that you subscribe to for each asset ID that you have, and um, you would send a URL with the API link, like you said, and then the wallet would request the CSV files from there, and then check if its address is inside of it. And then if it is, it would reconstruct the unrolls and provide an option to the user to complete those. I don't know if maybe it would make sense to just show it in your balance up front as well, since you know that the payment will eventually be created.
Yeah, in the balance, but not available.
Mhm.
So that would work if you can anticipate the airdrop happening. But let's say it's like an ecosystem airdrop and they just found your wallet address and you're getting a gift. What would be your favorite way to discover those?
Oh. Um, I mean, the only way I could think of there is to have a centralized like API that you call. You give it a list of your addresses, and it returns a list of bags that you're involved in.
Hmm.
Because
By the
there's
way,
definitely no way
oh,
to put data on chain without defeating the whole point of secure the bag.
it's a good idea. What I was gonna say, Jude, is once Brandon said bulletin subscription, that jogged my memory that the chip that's not really a chip yet, it's called bulletins. So I will need to discuss with the author of that to get it out there. So it does exist.
Cool.
Yeah, maybe there's a solution for this on the bulletin side of things.
Yeah, I know one tough thing about the bulletins is you have to subscribe to those messages. So you would have had to have had a priori knowledge of the minter or where the subscription is going to reside in order to be notified of that.
I
Um,
think with the current design, you can take the hidden puzzle hash of the revocable cat and find the Vulcan coin from there. So the wallet could do that automatically without you needing to go and subscribe to that yourself. But that doesn't handle non-revocable cats.
Yak, do you want to give some more details on your suggestions?
I was just thinking that the simplest solution is just, yes, you fetch the URLs through bulletins, but you also allow users to paste another base URL in case they are aware they received a gift. So the person posting will post, I sent NFT holders a gift, and then the base URL, which could be encoded like we encode offers. And then there's a place in the wallet where you paste the base URL, and the wallet checks if there's anything for it to claim.
That makes sense to me. I'm speculating about on-chain solutions. I'm wondering, I guess, Dan, if there's something as simple as like specifying the convention for what the memo should be on the root node. And I could imagine the memo includes a link to the manifest, which then anyone can inspect.
Ah, that'd be neat.
Or I guess you could send a coin with a hint being the asset ID of the cat rather than someone's address. And then the memo would have that link like you're saying. It just adds a lot of potential for someone to DOS all the wallet by just creating a bunch of these coins.
Fair, yeah. We want to avoid that.
I do feel like maybe we should specify the convention for the memo of the secure the bag root node, though.
Okay.
That way, if you see a bag coin on chain, you can reconstruct it.
Or you know what it is at least.
Yeah. I mean, I guess if the URL goes away, then you wouldn't have the CSV anymore. But
Well, we might have something in the works for permanent URLs too on Chia.
we do, like dig or something like that.
Something like that.
You know, fair. If dig is available to use, then we can link to a file on the dig network, and that can be the way. that we discover the manifest so that anyone can unroll them.
Hmm.
Hmm.
Another thing to ponder and possibly add to the chip. A lot of good suggestions today. Oh, I didn't see Slowest Time Lord's comments till just now, but he dropped off already. So. Oh no, he's still here. Somebody. Oh, I think he dropped and rejoined.
Yeah. John, were you interested in vocalizing those thoughts? Very well.
He is busy.
Well, just to recap for audio purposes, in the case of Bermuda doing the distribution, there might be taxable implications to think about in terms of when the unroll happens versus when the bag node lands, and there's nuance there. Um, so I guess we should know the nuance is my takeaway. I'm not an expert in that, so I can't say.
I feel like once the this is just my opinion, but I feel like once the root is created, the recipients basically have custody already, right? Like there's nothing that can happen other than them receiving this coin eventually, as long as someone pays for the fees to unroll it. So personally, that should not be any different than them owning the coin, but I'm not aware.
Uh, that would make logical sense to me too, but I'm not sure the way taxes work are not always logical. So this is not tax advice, folks.
That was also my assumption with clawback V2 is that after the clawback expires, then it's the same as you owning the coin directly.
Correct. Yeah. Yeah. In that case, though, it's just you and not this weird bundle with lots
Yeah.
of other people. But similar kind of thing.
Yeah, I guess you could argue that you're having to pay for fees for other people's unrolls as well, so slightly different than having complete ownership of it.
Correct. Yeah, I'm thinking that's going to be outside the scope of this chip because I don't want this to be about just Permuto. This Permuto is meant to be just one example or things that have value in the real world, I should say. This can be used for things that have no value at all.
That'll probably be what it's mostly used for.
Yeah, usually how it goes.
Sweet. Any further questions?
I guess one comment is that revocable cats have a slightly higher CLVM cost than regular cats, so I'm not sure if that would influence or impact the 100 coins per layer.
Oh, yeah. I'd have to look into that. I mean, 100 is a pretty safe amount. It's not like pushing it. So I'm guessing it still is fine with revocable cats.
Yeah, it's probably only like a 30% difference anyways.
Okay. I mean, there might be other assets. I hadn't really thought about that. There might be NFTs or something that could get so expensive that you wouldn't want 100. That'd be too much.
So for NFTs, we do 25 per. Um,
Yeah.
Well, I think for Secure the Mint with Mint Garden, at least when they're making offers out of these, they create like an XCH pre-launcher coin is the output of all of the bag payments. So you can still do 100 of them, and then the actual NFT mints are done individually with offer files, so that you don't have to pay the cost for those when unrolling. So if we do end up having a CSV format for revealing the unrolls, we might need to add these like constants that are in this chip into that as well, so you can customize it a bit.
Okay.
I can confirm we unroll directly for the secure the bag right now. We only use the pre-launchers for the secure the mint. Cool. Dan, what should we look for next in the chip?
Well, look for some updates from me based on this video. And once we have more of a working implementation, we'll get into review. I think that's a good idea. Or you can get into review. I'll ask you and move it along from there. So be sure to add your comments into the PR.
Sweet. Thank you, everybody. Thank you, Dan.
Thanks, Jude. Thanks, Brandon.
Yep. Thank you all. Have a great day.